Installing expansion couplings requires careful calculation to accommodate thermal expansion and prevent stress on piping systems. Here are practical formulas and considerations for proper installation. Firstly, let's look at the axial gap. The axial gap can be calculated using the following formula. Axial gap equals open parenthesis d times k times p close parenthesis divided by open parenthesis e times t close parenthesis, where d equals pipe diameter in inches, k equals expansion coefficient of the pipe material in inches per inch per degrees Fahrenheit, p equals expected temperature change in degrees Fahrenheit, e equals modulus of elasticity of the pipe material in pounds per square inch, and T equals pipe wall thickness in inches. Secondly, let's examine the restrained end moment. The restrained end moment, or MER, can be calculated using the following formula. MER equals open parenthesis d times k times p times L close parenthesis divided by open parenthesis 2 times t close parenthesis, where L equals length of the pipe between expansion couplings in inches. Thirdly, we need to calculate the expansion coupling size. The expansion coupling size can be calculated using the following formula. Expansion coupling size equals d plus open parenthesis 2 times g close parenthesis, where g equals axial gap required in inches. Additional considerations should be taken into account. Use the maximum expected temperature change for P in the formulas. For steel pipes, K is typically 0.65 times 10 to the minus 5 inches per inch per degrees Fahrenheit, and E is 29 times 10 to the 6 pounds per square inch. For plastic pipes, K and E vary depending on the material. Always allow for additional expansion due to potential thermal stratification. Provide adequate support for the piping system to prevent excessive deflection. Here's an example to illustrate the calculations. Let's calculate the axial gap and expansion coupling size for 6-inch steel pipe with a wall thickness of 0.5 inches and a maximum expected temperature change of 50 degrees Fahrenheit. First, we calculate the axial gap. Axial gap equals open bracket open parenthesis 6 times 0.65 times 10 to the minus 5 times 50 close parenthesis divided by open parenthesis 29 times 10 to the 6 times 0.5 close parenthesis close bracket, which equals 0.23 inches. Next, we calculate the expansion coupling size. Expansion coupling size equals 6 plus open parenthesis 2 times 0.23 close parenthesis, which equals 6.46 inches. These formulas and considerations are based on industry standards and best practices. Sources include the ASHRAE Handbook HVAC Systems and Equipment, the ISME B31.3 Piping Code for Process Piping, and manufacturers' technical manuals from companies like Victaulic and Metroflex. Understanding these calculations is crucial for ensuring the longevity and reliability of piping systems. The axial gap calculation is vital to ensure the expansion coupling can accommodate the anticipated thermal expansion of the pipe. If the gap is insufficient, the pipe may experience excessive stress leading to potential failure. The restrained end moment formula helps engineers determine the forces acting on the pipe due to thermal expansion. This is essential for designing proper supports and anchors that can withstand these forces and prevent excessive deflection or movement of the piping system. Selecting the correct expansion coupling size is crucial to ensure it can accommodate the calculated axial gap. An undersized coupling will not provide sufficient expansion capacity, while an oversized coupling may introduce unnecessary cost and complexity. When dealing with steel pipes, it's important to use the correct values for the expansion coefficient K and the modulus of elasticity E. These values are typically well established for common steel alloys, but it's always best to verify them based on the specific type of steel being used. For plastic pipes, the expansion coefficient K and modulus of elasticity E can vary significantly depending on the material. It's crucial to consult the manufacturer's data sheets to obtain the correct values for the specific type of plastic pipe being used. Thermal stratification can occur when fluids within the pipe are not uniformly mixed, leading to temperature variations along the pipe length. This can result in additional expansion beyond what is predicted by the basic formulas. It's important to consider this factor, especially in systems with low flow rates or large temperature differentials. Providing adequate support for the piping system is essential to prevent excessive deflection or sagging. This support should be designed to accommodate the thermal movement of the pipe while still providing adequate support. The spacing and type of support should be determined based on the pipe size, material, and operating conditions. The example calculation provided demonstrates how to apply the formulas to a specific scenario. By following these steps, engineers can accurately determine the axial gap and expansion coupling size for their piping systems. It's important to note that these calculations are based on certain assumptions such as uniform temperature distribution and negligible internal pressure. In some cases, it may be necessary to perform more detailed analysis to account for these factors. Consulting with experienced piping engineers and referring to industry codes and standards is highly recommended for complex or critical applications. Proper installation of expansion couplings is essential to ensure they function as intended. The couplings should be installed according to the manufacturer's instructions, and care should be taken to avoid damaging the coupling during installation. Regular inspection and maintenance of expansion couplings is also important to ensure they continue to function properly over time. This includes checking for leaks, corrosion, and excessive wear. By following these guidelines, engineers can ensure the safe and reliable operation of piping systems with expansion couplings. These calculations and considerations are applicable to a wide range of piping systems, including those used in HVAC, industrial, and process applications. Understanding the principles of thermal expansion and contraction is crucial for designing piping systems that can withstand the stresses caused by temperature changes. The use of expansion couplings is just one method for accommodating thermal movement in piping systems. Other methods include expansion loops, flexible connectors, and ball joints. The choice of which method to use depends on the specific application and the amount of thermal movement that needs to be accommodated. In addition to the formulas and considerations discussed, it's also important to consider the effects of internal pressure on the expansion coupling. Internal pressure can cause the coupling to expand or contract, which can affect its performance. The manufacturer's datasheet should provide information on the pressure-temperature ratings of the coupling. It's also important to consider the effects of external loads on the expansion coupling. External loads, such as weight, wind, or seismic forces, can cause the coupling to deflect or rotate, which can affect its performance. The supports and anchors for the piping system should be designed to minimize these loads on the coupling. When selecting an expansion coupling, it's important to consider the type of fluid being conveyed in the pipe. Some fluids can be corrosive or abrasive, which can damage the coupling. The coupling should be made of a material that is compatible with the fluid being conveyed. It's also important to consider the operating temperature of the piping system. Expansion couplings are typically designed to operate within a specific temperature range. Exceeding this temperature range can damage the coupling. The manufacturer's datasheet should provide information on the operating temperature range of the coupling. When installing an expansion coupling, it's important to ensure that it is properly aligned with the pipe. Misalignment can cause the coupling to bind or leak. The manufacturer's instructions should provide guidance on how to properly align the coupling. It's also important to ensure that the coupling is properly supported. Unsupported couplings can sag or deflect, which can affect their performance. The support should be designed to carry the weight of the coupling and the pipe. After installing an expansion coupling, it's important to test it for leaks. The coupling should be pressurized to its maximum operating pressure and inspected for any signs of leakage. Any leaks should be repaired immediately. Regular inspection and maintenance of expansion couplings is essential to ensure their continued reliable operation. The coupling should be inspected for any signs of damage, corrosion, or wear. Any damaged or worn coupling should be replaced immediately. By following these guidelines, engineers can ensure the safe and reliable operation of piping systems with expansion couplings. In summary, the formulas provided allow for the calculation of axial gap, restrained end moment, and expansion coupling size. Remember to use the maximum expected temperature change when doing the calculations. The expansion coefficient K and the modulus of elasticity E are important to consider for the different materials used in piping. Be certain to allow for any additional expansion due to potential thermal stratification, and make sure that there is adequate support for the piping system to prevent any possible deflection. The provided sources should be considered as references for the formulas and additional information on piping systems and expansion couplings.